Hi everyone. As I told you in class, we're going to start with the integral of trigonometric functions. To understand well how to obtain the integral of those functions, first we have to recall the derivatives. Here you have the derivatives of sine, cosine, tangent, cotangent, secant, and cosecant. And as I told you before, you have to memorize them. As you can see in all of them, you have sine of u, cosine of u, tangent of u. And when you find the derivative, let's say the derivative of sine of u equals cosine of u times the derivative of u. So I want to make sure you have clear this information. It means that we have to understand that this part is the derivative of the argument. In all cases, we have to find the derivative of the argument. Here we have the formulas for the integrals. So look at this. If you have the integral of sine of u times the differential of u, and we're going to talk about this differential of u later, the integral of that is the negative cosine of u, because the derivative of cosine is the negative sine. So as you can see in all of these integrals, those are the functions that have direct integral. The rest of them, let's say secant of u, cosecant of u, will require another technique, which is integration by parts. And then for tangent and cotangent, we're going to do substitution rule, or the change in variable. Well, if you look at your notes, we have exercise number 1, which is integral of sine of 4x times dx. But before we obtain the direct integral of it, we need to do a change of variables. So we're going to make u equals 4x, because that's the argument. So the differential of u equals 4 times dx. As you can see, we don't have here 4 dx. So we need, dx. So we need to do a change of variables. So this will be equals to the integral of sine of u times 1/4 differential of u. Because as you remember, in order to do the substitution, we need to divide this 4 dx by 4. So now we have the right substitution. This 1/4 is a constant, and then we have the integral of sine of u. Sine of u times du. And we have a rule for that. The rule for the integral of sine is negative cosine. And I'm using parentheses in order to avoid the mistake of making a product a subtraction. And remember that we have to add the constant. So this would be negative 1/4 times cosine of 4x plus the constant. How can we make sure that this is the right integral for that exercise? By obtaining the derivative of it. So I'll do the derivative in the next slide. So this is the function we found in the previous exercise. Now we're going to make sure that this is the right answer by doing the derivative. So I'm going to obtain the derivative of y with respect of x, which is negative 1/4 times the derivative of cosine, which equals negative sine of 4x times the derivative of the argument, which equals 4, plus 0, which is the derivative of the constant. So as you can see, Negative times negative becomes positive, and then 1/4 times 4 equals 1, and we obtain positive sine of 4x. And written as a differential will be the differential of y equals sine of 4x times differential of x. Now exercise number 4 from the notes. Again, we have the integral of square root of x times cosine of x to the 3/2 times differential of x. So we need to do a change of variable again for the argument. We're going to make u equals x to the 3/2. 3/2. So its differential would be 3/2 times x to the 1/2 times the x. But as you can see here, we have differential of x and square root of x. And that's what we need and what we have here to do the substitution. So all we have to do is to multiply by 2/3 times the u equals 2/3 times 3/2 times x to the 1/2 times differential of x. Now we are ready to do the substitution. So this will be equal to, I'm going to rewrite this integral. I'm going to do cosine of x to the 3/2 times x to the 1/2 times the x. Then, in order to do the substitution, we have the integral of cosine of u, which is the argument, and then we're going to multiply by 2/3 of the u. 2/3 become a constant. 2/3 times the integral of cosine of u times differential of u. And the integral of cosine is a direct integral because the derivative of sine equals cosine. So the integral of cosine equals sine of u plus the constant. And then to finish this exercise, we're going to do 2/3 times sine of x to the 3/2 Here we go. 2/3 of sine of x to the 3/2 plus the constant. And this is the result of that integral. The last exercise for this video is exercise number 3 on the notes. As you can see, is the integral of sine cube of theta times differential of theta. So first we're going to rewrite the sine cubed as the integral of sine square of theta times sine of theta times differential of theta. Now we're going to substitute sine squared by 1 minus cosine squared of theta times sine of theta times differential of theta. If you're asking yourselves why am I substituting sine squared this way, is because of the trigonometric identities. Then I'm going to multiply sine of theta times 1, and that will be sine of theta minus cosine square of theta times sine times differential of theta. Now we have two integrals. The first one, sine of theta times differential. Don't forget notation, please. Now, minus the integral of cosine square of theta times sine of theta times differential of theta. Differential of theta. Now we have two integrals. The first one can be obtained easily. So the integral of sine equals negative cosine of theta. And then for this one, we need changing variable technique. And we're going to make u equals cosine of theta. And its differential will be negative sine of theta times differential of theta. And we're going to do the substitution. So we have the first integral here, negative cosine of theta, minus the integral of u squared, which is cosine, times negative 1 times differential of u. Then we have negative cosine of theta plus u cubed over 3 plus the constant. Now we do the substitution. Negative cosine of theta plus cosine cubed of theta over 3 plus the constant. If you want to check this result, you can obtain the derivative. Remember that whenever you're working with a video, you can stop and go back as many times as you need in order to understand. I'll be around checking if you have questions.